Children, yesterday you understood about modes of heat transfer, right? So conduction you understood. Now second is convection you are going to understand. We know that conduction is not a very successful mode of transfer of heat in fluids. This is because the molecules are further apart. Hence, the chances of collision are very low. But when fluids are heated, the molecules near the heat source gain energy. As a result, they expand and their density decreases. So being lighter, they rise up. Okay. So their place is then taken up by cooler molecules. And cool air is dense. Okay. So this process is called convection current. The convection current is a process where warm air is light, okay, and cool air is dense. So when warm air inside the room, being it's lighter, it will always moves in a upward direction, and cool air which is coming from the window and the door, it will take the vacant place of warm air. Okay, so that is why ventilators provided in our room, so that warm air which we are breathing inside the room, it is being lighter, and being lighter it will always moves in the upward direction, and cool air coming from the window and the door, which take the vacant place of warm air. And this process, this cycle of movement of the molecules rotate like this. So this upward and downward movement of the cycle is known as convection current, right? So their place is then taken up by cooler molecules which are denser, and this process is called convection. And hence convection can be defined as a process of transfer of heat by the actual movement of molecules, and this cycle keeps on running and leads to setting up of convection current. Okay, so here one activity given, convection current in liquid. So to understand the process of convection in water, means in liquid, how it will work, you read here, you will understand how you will observe. It is observed that purple color stream rises from the crystal through the water after covering some distance. They spread out and come down along the side of the flask. So what is the conclusion? Conclusion, the molecules of potassium permanganate excite due to the heat given and rise up being lighter. So just I explained, light being a lighter, it will always rise up. Further, after reaching the top, these molecules cool down and move downward to take the space left by the lighter and hotter molecules. Okay, so this sets up convection current. Read this activity, you will understand properly more. Now convection current in nature means convection current in gas. How it works? In nature, convection currents are responsible for causing winds. So in coastal areas, you must have seen land bridge and sea bridge are the simplest example of convection currents. There is a lot of example I will give. First you understand land bridge and sea bridge. What is sea bridge, children? During daytime, the land gets heated up due to the heat of the sun more quickly than the sea. Okay, the air just above the warm land gets heated too. So this warm air rises up and the cool air from the sea rushes to fill its place. So this creates a circulatory movement of air from the sea to the land or coast. So since the cool air is moving from the sea to land, it is called sea breeze. Clear, children? Similarly, at night time, the land being a good emitter of heat cools down faster than the sea. Now the reverse process takes place. The hot air above the sea rises up and is replaced by cool air from the land, because land gets cool fast than the water, because once the water will heat up, it will get time to cool down. Okay, so in night time this happens. Therefore during the night, wind blows from land to sea. This is called land bridge. Okay, children. This is the example of convection current. So the monsoon is also a convection current set up due to the difference in temperature between the sea and the land. Hot air in summer rises up from the land and moisture containing cool air blows from the sea, thereby bringing rainfall on the land. Okay. So see here one more activity to demonstrate the hot air rises up. See this convection current in gas. This paper bag under the candle flame rises up because and the air above the candle flame becomes warmer and replaces the cold air in the bag. So the bag rises up. So conclusion, hot air rises up. Means warm air always rise upward direction. This one more activity to demonstrate the air transfer heat via convection. This also read. This is also nice activity you can do at home very easily. Easy activity. Okay children. Now some application of convection current. Many application: working of an air conditioner, working of a heat converter. Just I gave one more example. Why maybe ask in exam this question, why ventilator provided in our room? So this all the answer you are able to give now. So smoke and gas being hot rises and escape through chimneys in industrial furnaces. At homes, smoke and hot air escape through our ventilators, exhaust fans, through the exhaust fans. Now air conditioner and ventilator. It is recommended that an air conditioner should be fixed near the roof rather than the floor. Okay. So as cool air given by the air conditioner is dense, it settles down and the hot air rises up. The air conditioner then cools this air and the cycle continues. Just I had explained properly. In a similar way, ventilators at homes and in office helps in circulation of air so that our room will be fresh and cool. That is why ventilator provided in our room. Okay. Heat converter, that is also in winter we keep our room warm by using heat converter, or you can say heater. It must room heater also. It must be kept on the floor of the room and it heats up the air above it, which then rises up. The cool air comes down and which is again heated and the cycle continues and the room will be heated in winter. Now, so firemen usually crawl. One question may be asked, why firemen usually crawl while entering a building where fire has broken out? Because hot air and smoke always rise upward direction. Okay children. So this sea breeze, land breeze, monsoon are the examples of convection current. Ventilators, this room heaters, so many examples from daily life. You check, you observe and you will find out. Okay. Now radiation. In radiation, just I had explained, in conduction, in convection there is a medium required, but in radiation no medium required. Okay. How? Just see here. When you sit in the sun or in front of a bonfire, you will feel warm. The air between you and the heat source is a poor conductor and does not get heated. This is to say that heat is not transferred through conduction. Convection is also not possible in this case, as convection current rise up vertically upwards and not sideways, right? So what is this medium called? When you sit up in the sun and in front of the bonfire, you will feel warm through the process of radiation. So further, if you put an insulating material like a cardboard between the fire and yourself, you will not feel hot. This shows that even when the air around the remains cold, the heat is being transferred from the heat source to sun. Clear? So that is the process. This means there is a third method of transferring heat which does not require a medium. So in radiation there is no required any medium. Hot and cold bodies, between hot and cold bodies. So is known as radiation. Clear children? So radiation is the process of heat transfer from a hot body to a cold body without affecting the intermediate space or in the absence of any medium. In radiation, heat travels in the form of waves from the hot object. Okay, and the higher the temperature, the greater will be the radiation. The heat that comes out of the hot object is called radiant heat. So all bodies absorb and emit heat. When heat falls on any object, a part of the radiation is absorbed and a part of it is reflected. So the absorption of radiation causes a rise in the temperature. Clear, children? So some activity, some examples given. You read properly. This is also very easy. This shiny surface, poor absorber and radiator of heat radiation. Why? You read this, you will understand. And next topic, next day. Some application of heat radiation in next class we'll discuss. Up to here, revise. Okay.